In this lesson, we actually learn how to compare apples and oranges. So, let's start with our example and take a look at it. Adult male heights are on average 70 inches, 5'10", with a standard deviation of 4 inches. So I'm just going to kind of write that. Mu for men is 70 inches, and the standard deviation for men is 4 inches. All right. And then, so those are our numbers. Adult women are a bit shorter, and that's kind of what you expect. The average for women is 65 inches, or 5'5". And the standard deviation, the spread, is 3.5. I actually got this off of a usable statistics website, and these are the numbers they gave for our population here in the U.S. Okay. So I've got two people. I've got Laura is 72 inches tall, and Mike is 77 inches tall. Who's taller compared to their averages? In other words, who's more unusually tall? So Laura is 72 inches tall, so she would be minus 65 inches. She's 7 inches taller than average. That's pretty good. I wish I was taller than average. All right, and then Mike, well, he's 77 inches taller. 77 inches tall, but his average is 70 inches. So he's also 7 inches taller than average. Well, who's more unusually tall? Well, let's find out. Well, what we're going to do is use standard deviation. That's our measure of spread, of how far apart our groups are spread out. Okay? So how many standard deviations above average? This is going to be what's called a z-score. This is very important. So z for Laura, we basically find out, okay, well, she is 7 inches taller than average, right? And if I divide that by the typical width for the spread, I get 3.5 inches as a spread. It's 2. So she's 2 spreads above average, 2 standard deviations above average, all right? If I do it for z-score for Mike is 7 inches over 4 inches. He's 1.25 inches taller than average. I mean 1.75, and it's not inches. It's spread, 1.75 times the spread. So who is taller compared to the respective group? Actually, Laura is. Because 2 is greater than 1.75. All right? Now, this results in a formula which we will be using. We call this a standardized test statistic. So if you ever took an AP test and they said, oh, what's the test statistic? It's x minus the mean over standard deviation. The way you'll see it written is usually this formula right here. Voila. So that's an important formula. We're going to be using it for about half your assignment. Okay, so now we're going to compare Amy's SAT score to Maria's ACT score and how they did. Well, for Amy, she scored a 17 ACT, and Maria scored a 30 on the ACT. So let's see. X for Amy is 1740. That's what she got. And X for Maria is 30. The mean score for the SAT is 1500. That's for Amy. And I could have said SAT and ACT, but we'll live. And the mean for Maria's type of test is 21. All right. Standard deviation is, for the SAT, is 240. And standard deviation on the ACT, we don't expect it to be so many points spread out, is actually 6. So the question is, who scored better? Well, we're going to use this formula. We'll say the z-score for Amy is 1740 minus the 1500 divided by 240. All right? 240 over 240, which is 1. For Maria, her z-score is 30 minus 21 all over 6, which is 9 over 6, which is 1.5. Maria did better because she had the higher z-score. All right. This is true. Before my mom passed, she was 4'11", So if I go back to the other numbers I had before, what is the z-score for her height? Well, 4'11" is basically 48 inches plus 11 inches, 59 inches. That's how tall my mom was. So her z-score is 59 minus 65 all over 3.5, which is about negative 1.71. Why is it negative? Well, that happens when you're below average. And while I adore my mother, her height was definitely below it. By the way, my dad is 6'11", and so there was quite a discrepancy in their heights. Now, I actually updated some of the numbers. I had some kids go to Hawaii, some of the royalty, and so I said, hey, let's make up a problem about Hawaii and Alaska. And I actually had their temperatures that I made up over here. And the question is, one day, the average temperature for this day in March is 28 degrees, and the actual temperature was 24 degrees. These are all Fahrenheit, by the way. And in Hawaii, the average temperature is 80.2 degrees, and the temperature they measured that day is 77. So both are colder than average. But who's more unusually colder? Well, let's do the z-score for Alaska. All right, it's going to be the actual measurement minus the mean. Don't switch these, because remember, you have to do the actual minus the mean to know if you're above average or below average. Divided by 10. Negative 4 over 10, or negative 0.4. So it's negative 0.4 standard deviations below the mean. Hawaii, on the other hand, Hawaii, my husband actually grew up there. Lucky guy. 77 minus 80.2 all over 2. So let's see, 77 minus 80.2, that would be 3.2 all over 2. And if I take 3.2 divided by 2, did I do that right? Yes. I get 1.6. And that's negative 1.6. So Hawaii is more unusually cold. Right? Unusually cold. So that's how you can compare the temperature for a day in Hawaii to a day in Alaska and figure out who is colder.